All right, to get the number of network bit, right? The formula is basically 2 is power n, or 2 is the power, 1 second, 2 is the power, you can say x. Now x, how will this x will come up? Consider this 2 is the power x in this, right? So where x is basically the one on bit. So x means on bits. On means 1,
1.
right? So yes, on means 1. And this is the formula to get the number of bits. Number of as an on bits. Next is to get the number of valid IP addresses, or can say host bits, right? 2 is the power y minus 2. Where y is off, and off bit means
0.
yes, so where y is 0 and 0 is called off bits, right? So we will now calculate based on this formula. We'll take one example and calculate based on this formula. But further, there are 2 more formulas to get the block size and all. So to get the block size, formula is 256. Why 256? Because the whole range of the IP address will start from 0 and will end at 255.
Right.
So including 0, it becomes 256 minus sum of on bits. Sum of on bits, right? So whatever it comes, on bit means
1.
1. And to get the subnet mask, formula is default subnet mask, because we have seen there the default subnet mask will be there for class A, class B, and class C. Default subnet dot, so whatever default subnet is, but dot 250, no, default subnet dot sum of on bits. So these are basically the 4 formulas. 2 is the 2 is to x. This formula is to get the number of on bits. 2 is power y minus 2. This is to get the number of host bits. To get the block size 256 minus sum of on bits. And to get the subnet mask, default subnet mask dot sum of on bits. Now let's say I'll take class A. For example, I will take class A. So under class A, any IP address can you tell me? Any range of the network you can tell me. So let's say private
10,
IP address 10.
10.0.0.0.
All right. So now with this 10, what will be the default? The default subnet mask will be
So the host bit is 24.
255.0.0. This will be the subnet mask.
So this is what I don't understand. I mean, not that I don't understand. It kind of creates confusion.
No, so this is default subnet mask. That's what we have gone through, right? Based on
Okay,
the
so
class.
right. Because the network bit is 8-bit is all full, so it's 255.
Correct. Now
Okay.
let's put this into the formula, right? This I am doing the class. So there are actually two types of IP subnetting. One
Yeah.
is uh,
Yeah.
class full subnet and one is classless.
Right.
So this we are doing class full actually.
Okay.
All right. So in this, let's put into the formula. To get the number of networks, how many networks we will have, it is 2 is the power x. So where 2 is the power x means number of on bits.
Right.
So 2 is the power 8 because we have 8 bits in this.
Right.
This is default, right? So 8 bits, 2 is the power 8, what you will get?
2 times 2, 4. 2 to the 4, 4, 8, 16, 32.
32.
I think so.
Check it again. 2 is power 8,
2
which
raised
means
to 2 is 4. 4 raised to 2 is 8. 8 raised. Oh, wait. Uh, 1 minute, let me check.
so it is something like 2 multiply by 2 like this.
Yeah, that
So 1, 2, 3, 4, 5, 6, 7, and 8. So 4 multiply by 2, 8 multiply by 2, 16 multiply by 2, 32 multiply by 2, 64 multiply by 2, 128 multiply by 2, 256.
so 2 raised to 8 equals. No, this cannot be right.
So basically what you will get here is 256.
256. Yeah, I got 256.
Right?
Okay.
So now the number of this number of network bits will be 256. Means these are the total number of network, isn't it?
Yes.
Right? Now let's get the other two number of host bits. Now the number of host bits, what will be the formula? Again,
Uh,
2 is power y minus 2,
right.
where y is off bits. So how many off bits we have?
We have 24 off bits.
We have 24 off bits. So 2 is 2 24 minus 2, isn't it? So
2
that
raised
will
to
be
24.
the calculation. So now if we calculate, it will come too much,
Right.
right? So it is like 2 is to power 24 because we have 24 bits and minus 2.
It's 1 crore 67 lakh 77,216.
Exactly. So this is actually these many IP addresses. For example, let's say, so number of host bits 1 crore 67, and let's put like this,
Hmm.
right? So these
Hmm.
many IP addresses you will have in one network,
Right.
right? So that, so how many total network we have now? We have 250 256 network in
Hmm.
this by default, right?
Hmm.
So these many IP addresses you will have in each network.
So, okay, now this is a confusion. So 256 is 256 separate networks.
Correct.
Okay.
Where the 10.0.0 is one of the network.
Okay. So in each network, you have 1 crore 67 lakh IPs.
Correct.
Okay.
All right. Then the to get the block size is basically, it decides how many particular, what will be the block of this network. What will be the block of this network.
Hmm.
So the block size will be like 256, as I told you, minus sum of on bits. Now I have how many on bits here? 8 bits,
Hmm.
right? In previous example, if you have noticed, if 8 all bits are on, and if I calculate sum it, what I will get to 55,
255.
isn't it? So 256 minus 255, I have got block sizes in 1,
Hmm.
right? Now, I'm sorry, no, not here. As of now, block size we will get as in 0. So block size is in 0 because as of now, the sum of on bits we are only getting in the the network portion. We are not getting in the host portion, right? The way we have put it there, sum of on bits in this, right? So I have 10.0.0.0, 8 bits we have network, but in host portion I don't have any on bit. So 256 minus 0. Anyways, by default, in class full, the block size will be always 256. Consider this.
Okay. Why not 255? I forgot.
No, the 256 because any IP address will start with the 0
Hmm.
and it will end up to 55. So total to
Right.
56. So
Hmm.
in any of the class full network, your block size will always constant to 56.
Hmm.
And the subnet mask will also be constant, as in the default subnet mask.
Which is
255.0.0.0.
okay.
So if it is class A, if we are doing class A, in that case class A subnet mask. If we are doing in class B, so class B subnet mask.
Hmm.
Now the rule is the first IP of this network will be always a network address. So like 10.0.0.0, this is the
Hmm.
first IP, isn't it?
Hmm.
So this will be called as an network address,
Hmm.
right? This is the first IP. And the next IP will be as in the valid IP address. So this is the valid IP address,
Hmm.
which means this IP address you can assign to the network, any of the host,
Hmm.
right? And then this will keep on going 0.1, 0.2, 0.3, 0.4 till 0.255,
5.
and once it becomes 5, this 0 will become 1,
Hmm.
right? So it will go till 255, and then it will become 10.0.0, 1.1
1.0, no?
no, 1.1, 1.0 won't be used.
I see.
So 1.1, and then again it will go till 255,
Hmm.
and then again it will become 10.0.2.1, and then again it will go till 255, and
Hmm.
that is how this will this the last address will be
255.2.
10.255.255.254. This will be the last valid IP address,
Hmm.
and the last address of this will be 255 this, and this is called broadcast address.
Okay.
So this was the first address, right? First valid IP address, and this is the last uh, and this is the last valid IP address. So this is the range of this valid ring network. These many IP address, that is how it comes 1 crore 67 lakhs something,
Hmm.
right? Last network address, what it does actually, it represents the number of valid IP addresses in that network. So if I advertise, or if I advertise this network to router, so router will consider that this particular network has got 1 crore 67 lakhs valid IPs. Anything in between comes, right? I will consider that this is the part of this network and will send it accordingly.
Hmm.
Clear?
Yeah, so this is for the class full.
This is for the class full.
So for the class full IP, basically it's pretty straightforward. If it is class A, then 8 bits network, 24 bits host, and subnet mask is 255.0.0. Uh,
Correct. Let's take one class B IP address.
so the network bits is 256 because it's 255 plus 1. But when it will come down to class B, the network bits will change.
Yes, now here it will be 2 is to 16. 2 is power 16. Because now 16 bits we have for network. And the host bit will also get reduced.
Right.
Right, so let's take class B any IP address, maybe private 172.16.0.0. Right.
Right.
So now in this, just make with the same formula and everything, keep it here, and just let me know what will be the number of network and valid IP addresses. So in this, now we'll start classless, right? So in this
No, no.
classless, what I'm saying,
Okay, what were you saying about 254 valid IP address?
in class C, by default 254 valid IP address in one network, right?
Okay.
So how service, we have already gone through that how the customer will get the IP address. It is like ISP, isn't it? From
Mhm.
ISP, the range will be given to the customer, isn't it? Now assume that this customer need only 50 valid IP address. Okay.
Mm.
So since it is 50, requirement is 50, what ISP will do, ISP will give any of the network, maybe 192.168.1.0 to this customer, or
Mm.
2.0 or 3.0,
Mm.
right?
Mm.
Now this customer will use 50 IP address.
Mm.
But in class C by default, how many valid IP address will be there total in one network?
254.
254, right? Now this, in this case, this customer will utilize 50 IP address, but 204 IP addresses will be waste,
Right.
right? Because neither service provider will be able to give this network to anyone else,
Mm.
and customer doesn't have machines to utilize.
Mm.
Correct. So now this is kind of the wastage of IP address. So now what we have is classless. So in classless, it will divide basically the big network into a small network. In order to do that, we use CIDR. Why it is called classless anyways? It is called classless because now there is no class. After using CIDR, CIDR full form is classless interdomain routing.
I see.
Interdomain routing, right? So now using CIDR, as I told you, there won't be any class. It will be a classless. So even if
Mm.
I have class, let's say, we'll take 192, one IP address.
Mm.
Let's say class C will take 192.168.1.0. And in this class full, we have seen by default 254 valid IP address will be there,
Mm.
right? Now this last host bit, what ISP does actually, subnetting means in the host portion, this zero means how many zero? 80, right?
Yes.
So I'll just to make you understand, I'll put it like this,
Mm.
80, right? Now what service provider does, it 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 actually plays with these host bits.
Mm.
So what it will do, it will turn one bit on from the host portion, left to right it is always,
Mm.
right? It will turn one bit on from host portion. So now we
So,
had 24 bits on by default, plus I have got one more bit,
so who will make this happen? One bit
service
on.
provider,
Okay.
right? So now this will become slash 25.
Mm.
25 means this after slash whatever, which means that many bits are on.
Mm.
So now 25 bits are on,
Right.
right? So let's, now since we have 25 bits on, where is eraser?
So does the classless mean that you take away bits from the host and not taking away bits from the network, or it goes both ways?
It will be from the host.
Okay, so then supernetting is taking the bits from the network, something like that?
Yes, supernetting will take the bits from the network, correct.
Okay, okay. I'm just guessing.
Yeah, that's true. All right. So in this, to get the number of network, formula was 2 is the power x, isn't it?
Hmm.
Now here, remember, we will be talking about this. This is anyways default, isn't it? 24 bits. This is actually the default,
Hmm.
right? So we'll say 2 is the power x means what will come here? 2 is the power. How many bits on we have in the host portion?
On the host portion,
Yes,
7.
on. 2 is power
On 1. 1.
1, right? So the value will be 2,
Hmm.
isn't it? Which means if service provider gives me slash 25, the total number of get network I will get is 2.
Okay.
And to get the valid host, y minus 2, this is the formula. And what you will get, how many host bits we have in the host portion?
7.
7. Let's
Right.
solve it. 2 is power 7 equal to minus 2. What you will get?
128.
128 minus 2. 126.
6.
So 126 means each network, I have two network, right? Each network, the valid IP address will be 126.
So here the network block will not be 256.
No. So in
Here
this
the
case,
network block is only 2.
block. No, let's talk about now block size.
Because this is not touching the network bits at all. This is only touching the host bits.
Correct. But in host bits, we have network bits, right?
So inside the host bits, they give the network bits and that's how they calculate, but they do not touch the network bits at all.
No. So this was block size 256 minus sum of on bits, right?
Hmm.
So in this particular portion, I see one bit is on, and what is the value of this bit? 128,
128.
right? So now 256 minus 128.
Hmm. That's 128.
You will get 128 again,
Right.
right? So the block size will be 128. What is block size now? This block size means one network will go maximum from 0 to 128.
I see. And we
Right?
have two networks like that.
Correct. And then let's talk about the subnet mask. What is anyways default subnet mask? Default subnet mask is 255.
255.0.
Or
255.255.255.0.
correct. Now, not 0. As I told you, if you go to the previous slide, there I told the default subnet mask dot sum of on bits, isn't
Right.
it?
Right.
So sum of on bits mean on bit I have 1 and the value of that bit is 1.
128.
The value is means 128. So the block, the subnet mask will be 128. 255, 255, 255.128.
Hmm.
And what is anyway subnet mask? Subnet mask is which tells you the number of network bits and number of host bits. By
Hmm.
putting this subnet mask, I will get to know 24 bits and one more bit on. So total 25 bits are on and 7 bits are off. Or 25 bits for network and 7 bits for host. Isn't it?
Right.
So that way I have two network now. Clear? That way I have two network. 192.168. The first network will be 192.168 1.0.
Okay.
Because anyways it will start with the 0, right?
So even though it has a one network bit, it will still start with 0?
Yes.
No, it will
So
start with 128.
I'll tell 192.168 and dot 1. This was the first address, isn't it?
Right.
Since it is saying there are two network in this now, है ना? So in this two network we have, and the block size is 128, which means the first network will go from 0 to 120.
8.
Now if it goes to 128, so it will become one total 129 because 0 will also be counted.
Right.
So from 1.0 to 1.127, isn't it? Then it will become 128, right? 0 and 127, 128.
Right.
So now the first address we have already seen. The first address is called network address, isn't it? Last address is called
Broadcast.
broadcast address. In between, we have how many valid IP address it is saying? 126.
Right.
So from 1.1 to 1.126, this will be the valid IP address. Valid IP address. Clear? This is your first network.
Right.
Now the second network. Second network will start immediately from where?
From
128.
190 to
Now
160,
after 127, what is there? 128.
128.
So the second network will start. Now this is the first IP of the second block.
Right.
So this will become
Network address.
network address. And it will go till add 120, add 128 in this. What you will get?
256.
Now 256 you cannot, because 128 also you have to include, which means 120, 250,
255.
255. This is the last address. So it will become
Broadcast.
broadcast. So the valid IP address will be 129 to 250,
254.
254, and they will be the valid IP. So this was my first network anyways, isn't it?
Right.
And the second network is this. That's what this formula is saying, that I have two network. Each network will have 126 valid IP addresses, right? Where the block size will decide what will be the block and the subnet mask. Isn't it? Clear?
This is very, very hard. It's not easy to remember and
Yes,
uh,
it is not, but we need practice. In fact, if this IP addressing, just trust me, till the time you are, in networking field, these things will keep on coming. So it is good that you clear your all doubts now only, and you become master in this now only.
Mhm.
Right? So you need practice, and then you have to take all the blocks and then understand, okay, that is how it, the bits coming and all.
What do you mean by practice? How will I practice?
In the same way, if I give you, okay, 192.168.1.0/25, take it out, what you will get the network, how many network, how many, what will be block size, what will be valid IP addresses and all.
I see.
If I give you, okay, /27,
So
and no,
today,
this is not done yet. There are a lot of things in this edge.
today's world, they mostly use the either the subnetting or supernetting, right? Only classless. Classful
Correct.
nobody use anymore.
No, nobody uses classful.
Because especially for the hosting environment, it is lot of waste of IPs if you use classful.
Correct.
Mm.
All right, this was class C and the first bit where we turned it on. Now
Mm.
think from that perspective, I still need 50 IP address. The customer still need 50 IP addresses, but in this, service provider is still giving how many? 126 valid IP addresses. Fine, 50 I will use, but still 76 IP addresses still getting waste,
Mm.
isn't it?
How
So
come 76 is wasted?
50 I am using, total 126, right? So
On the
76,
one network, right?
yes.
Okay. Yeah, wastage.
Right. So now what I'll do, or what service provider will do, in that case, service provider won't give you this block. Service provider will give you, it will say, okay, in that case, the next is, so this you have understood, right?
Yes.
Okay.
You recording, right?
Yes, the recording is going on.
Okay.
Now, in this itself, I'll give you one more example and then I'll ask you to do it yourself. Let me clear it. All right. So this was /25. Now in this we have got the basic idea. Now what happens when the next comes, right? As I told you. So what service provider will do to divide more number of network in this from this host part, it will turn one more bit on.
Mm.
So that now will become /26,
Mm.
right? Now
Right.
you have to put into the same formula, isn't it? 2 is the power x, where the
X
x
is
means 2 is the power 2,
right.
right? So 2 is the power 2. So total of network now
4.
4. Valid IP address 2 is the power
Y.
y means off bits. So 2 is the power 6
6.
minus 2
Right. 2,
equal
4, 4, 8, 16, 32, 64. 64 minus 2, 62.
62.
Mm.
Block size 256 minus sum of on bits. Now here I have 128, the first bit,
Mm.
and
Mm.
plus 64, the value of the second bit,
Oh, I see.
isn't it? So what you
Right.
will get? 192. So equal to 64. Now the
Mm.
block size is 4.
Block size is 64. Okay.
Correct. Subnet mask. Default subnet mask 255 dot 255 dot 255
.0.
not dot 0 but sum of on bits. So 128 plus 64 192,
Hmm.
isn't it?
Okay.
So 192. In
So
previous
here
example,
there is two confusions. One is I do not remember how did this 256 came in this formula.
no, 256 is by default because any IP address will go from 0 to 255.
Okay, okay, okay. So uh, that one octet is 256.
Correct.
Okay. Uh, no, that's not octet. That's just IP addresses. Dot 0 to dot 255.
Mhm.
It's not considered as the octet, right? Like,
No, in first octet anyways, in first octet, if you turn all bit on 0, it become and it if you turn all bit on 255. Now
right.
including 0, it becomes 256.
Okay. So this one is 255.255.255, and the total of the 2 on bits.
2 on
That's
bits,
what.
correct.
Okay, so this becomes the network address.
Subnet mask,
Subnet mask.
right? Now in this formula, I have 4 network if you see,
Hmm.
isn't it? So
Right.
fine. 192,
Dot 168.
168
Dot 1 dot.
dot 1 dot 0.
Hmm.
This will be the first network because this is the first IP,
Right.
and it will go till 1 dot. So now
Hmm.
block
Wait.
size is 64, right? So
Block
you say
size.
this one. This is the first network. Second
Right.
network will start after 64. So the second network will start 64.
65, no?
64. The third network
Okay.
will start 64 plus 64 equal to 128.
Okay.
So the third network will start 128.
Hmm.
And the fourth network will start
256.
220, 224. 128 plus 64 equal to
Okay. To 280, 292.
192 in that case.
190.
192. Right. So now this is the another network. This is another network,
Hmm.
and this is another network.
Hmm.
So before 64 it is 63. So 63 will
Hmm.
be broadcast address.
Right.
127 will be broadcast address,
Right.
right? And 191 will be broadcast,
Right.
which means 1.1 to
To 1.6.
1.62
Hmm.
will be the valid IP address in first network. 65 and 126
Hmm.
will be
The valid IP.
correct. The valid IP, and 129 till 190 valid IP, and 193 till 254 valid IP. The last address will be 255. So that way we have 4 network. One network, second network, third network,
Hmm.
and fourth network.
Right.
Now it makes sense where I need 50 IP. So I have 64. So I can still use 50 and 14 IP addresses. I can keep it reserved.
Hmm.
isn't it?
Right.
But what if any customer need 30 IP address or less than that or something?
So if you do the half, it automatically becomes 32. So slash 27 will make it 32.
Exactly. Right. So this was slash 26. Now let's do slash 27. So this 26 is clear, right?
Yeah.
Now slash 27. Since slash 27, I have 3 bits on,
Right.
right? So let's take it out. This will be a homework for you, as in this will be a solution. So just solve it. Number of network, number of host, all bits, and just let me know what will be the how many network and each network address and broadcast address and all.
Now or for tomorrow?
Now only. For tomorrow, I'll give lot.
So I need the formula. Um, okay.
This is your 2 is power y and 2 is power x.
Block size, get the block size 256 minus on bits, and 2 is to power x, 2 is to power y minus 2. Okay. So, okay, let's go down.